Hello friends, so welcome to Cadence tutorial. I am Madan Kumar Jain. Today I am going to create a mask using Pass Transistor Logic. So before that I have to make a schematic of a mask using Pass Transistor Logic. So I am going to create a cell view in Cadence tutorial library. The cell name is basically mux ptl. Okay. So for making a mask using PTL, I have to instance two NMOS. So in GPDK 180, I am going to search NMOS. So this is the symbol of NMOS. Okay. Now the source of this NMOS should be connected with voltage source, and the drain will give output. So both drain of this NMOS will be connected to each other. Then I have to give signal to this source of both NMOS. So I am going to generate a pin which is input type. Okay. Now for wiring, press W and connect the source of this NMOS with the pin. Then there we will supply signal in the form of a voltage, and here the select line of the MOS will be given. So for making a 2 to 1 mux, I have to take one select line. So I am going to generate a pin which is also input type, and going to make a select line S and S bar. Okay, S bar. Okay, so this is the select line for the mask, and this is the input. Now I have to keep the control voltage everywhere. So for providing control voltage to select line, the control voltage which will be provided to S, the inverting version of that control voltage will be provided to S bar. So go to instance, then analog library. I will find peoples. So searching for peoples. Voltage 1 is 1.8 volt and voltage 2 is 0. The period of this pulse signal will be 10 nanosecond, and I'm going to change its pulse width to 5 nanosecond. Okay, then rotate this. Okay, hide, and I'm going to invert this source voltage, so I have to make the V2 as 1.8 volt and V1 as 0. So press Q, go to properties and change its voltage 1 to 0 volt and voltage 2 to 1.8 volt. Okay, period will be same. Now going to connect this both terminal of gate. Again go to instance, then analog library, search for ground, then rotate this, connect both negative terminal of V pulse to ground, and the bulk of the PMOS should be connected with ground also, so connect it with ground also. Okay, so I have given the S and S bar signal to this mask PTL. Now I have to give two more signal A and B to this mask. So press I, again go to V pulse, then make voltage 1 as 1.8 and period I am taking 20 nanosecond and pulse width at 10 nanosecond. Okay, so this is the pulse for A. Now again I am going this pulse to B, but I want to change its period for C, a correct waveform in output section. So change its period to 30 nanosecond and its pulse width to 15 nanosecond. Then height. Okay, so I have to enter here. Okay, now I have to connect the negative terminal of this V pulse with ground. So copying, I'm going to copy this ground using C and then connect it with the negative terminal of V pulse, and the positive terminal will be connected with A and B. Okay, so W will connect this to okay, escape. The output of this must will be connected with a pin, so I'm going to create a pin Y for seeing the output, height, and join this pin with this net. Okay, now I think everything is fine, so go to check and save and see whether your schematic is correct or not. So my schematic check completed with no errors. Now again go to launch ADL, so go to session and then right click here, go to edit. I'm taking 300 nanosecond as a transient time this time, and okay, then edit. From design I'm choosing all the input and output, so A, S, B, S bar, then output. Okay, so this all output nodes have selected. Now go to ADL launch setup in model libraries. Okay, so GPTK180 is already selected. Now run this simulation. So this is the output waveform of the mask using fast transistor logic. So expand this all. Now you can see when okay, I'm going to make it mode wider. Okay, so you can see here a mask is basically a 2:1 mask. Output is given as y is equals to s into a plus s bar into b. So when s and a both is 0 and b is also 0, so 0 into 0 is 0 and 0 into 1 is 0, so 0 plus 0 is 0, so output is 0. So when the select line s is 1, here both, when the select line s is 1, it will sample a. When the select line is 0, it will sample b. Okay, so here when select line is 1, a is 0, so output is 0. Okay, when the select line is 1, here a is 1, so output is 1. And when s bar is 1 and b is 1, it is 1. Okay, so 1 into 1 is 1, 1 into 0 is 1, and 1 plus 0 is 1. Here again 1 into 1 is 1, 0 into 0 is 0, but 1 plus 0 is 1, so it is 1. So the mask is working fine. So this is 2:1 mask, 2 cross 1 mask using fast transistor logic. In further upcoming videos, I will use this mask for making the schematic of AND gate, OR gate, and XOR gate, and some other circuit. Okay, so thank you, student.